Welcome, ladies and gentlemen, to the Tactical Generator Monitoring System Sprint 5 review. Here's our agenda for today. And here are our team members.
The Tactical Generator Monitoring System is a power monitoring device intended to save American lives. There are enemies inside the wire, and their names are wet stacking and overloading. Fuel must be brought to forward operating bases by ground vehicles in order to be cost efficient. This operation costs lives every year as insurgents plant improvised explosive devices and ambush caravans. Service men and women are fearing for their lives. This process can be reduced by using fuel and generators efficiently with our product. No country should allow deadly inefficiencies. Our vision is to create a product that can conserve fuel and prolong generator health in order to reduce the amount of dangerous caravans bringing fuel and generators to forward operating bases. Members of this project will lead these soldiers in a year. They are motivated to put out a quality, effective product as it may be their soldiers that are put in danger. This product has been developed by multiple classes of electrical engineering majors, IT majors, electrical engineering Army officers, and United States Military Academy professors. It was also presented at the Army Research Lab in the fall by Cadet Anderson. Our plan is simple. The Tactical Generator Monitoring System team hopes to create a monitoring system for all Army microgrids in war zones around the world. These systems will flawlessly integrate in their microgrids using a simple series connection between generators and loads. We promise to design the most robust, applicable product in our power. Please enjoy the progression of our project. The U.S. Army continues to be on the forefront of effective militaries. We will not waste the taxpayer money and lives.
The product background slide describes the why. The high-level product diagram describes the how. The TAC-Gen will measure the output of the military generator using straight plug and wall mount connectors. Current transformers will measure its current, and the voltage transformers will measure the voltage. The A/D converter outputs digital signals, and using C++ Fourier transform algorithms, we are able to calculate the phase and amplitude of the power. We can then do three things with this data: store them in a database, display them on a GUI, or analyze the data on a computer.
The goal of Sprint 5 is to produce testing results by integrating the assembled product with the working code and prepare for project day. Our capacity. Our expected hours was 168 hours. Our actual hours is 168.5 hours, and our scope is 1.003.
This is Cadet Peringer. For this sprint, I worked to integrate and test the A/D converter. I assembled the tactical generator compatible connectors. I recreated the team quad chart, worked to humanize the group members by creating individual biographies, and I started initial talks with the ESG for Project Day. I had to switch away from research to work on selling the project and our results at Picatinny Arsenal on Project Day. I'm currently working to reword the Picatinny Day poster board to be more concise and to finish up the team bios for Project Day.
This is Cadet Anderson. For this sprint, I had the goal to complete the electrical hardware design and implementation for the TGMS. On this slide, you can see all of the goals I wanted to accomplish. I first wanted to finalize the hardware schematic in Multisim. Next, I needed to export it to Ultiboard and begin the process of designing the printed circuit board. I worked with ESG for a large portion of this process, and they helped me greatly with their assistance and expertise in these programs. Finally, I had to work extensively with ESG to prepare for Project Day. This work included developing a plan to access three-phase power in the ballroom, as well as making a plan to interface the TGMS with the load. As far as finishing the PCB, I have all the components completely soldered by today, except the current transformers. I will test the board and hopefully transition to working with Ari and Christian to properly interface with the software components of the project. I was unable to complete this goal for the sprint because I underestimated how much time it would take to work with ESG in designing the PCB and planning for Project Day. This slide demonstrates the final schematic design for the TGMS. It includes the 3 voltage transformers for each of the phases of power that we will be monitoring, as well as the 4 current transformers to monitor the power and the neutral line of the system. The final design includes an offset circuit that was tested and verified to make sure the signal we are transmitting to the Raspberry Pi is within the 3.3 maximum voltage limit and does not transmit negative values. This slide demonstrates the final printed circuit board design for the system as seen in Ultiboard. Finally, the board has been printed and fits in the casing we have prepared for the monitoring system. Final preparations include soldering all remaining components, testing it, and interfacing with the software.
For this sprint, I helped develop the Picatinny board and integration of the load into our project. The load was developed by Dr. St. Ledger for one of his projects. He's letting us use it to act as our load for this project. We will use it to simulate a fob that is powered by our generator. I worked with CSG to develop a schematic of the load and discussed how to connect our three-phase power system to the load. Right now we are just waiting for CSG to connect our three-phase power to the power strip. I also worked with Vios to order additional monitors for Project Stay.
Did you take a speed course? Can you slow down?
What's some inflection?
This is Cadet Bondoc. The priority of this sprint is to prep for Project Stay and to reorganize all materials and research for the next year's iteration of this project. To do so, we focus on the documentation of the code, designed and printed out our Project Stay trifolds, and perfected our pitches. My peer Ari attended the Picatinny Arsenal and presented our project there. We were unable to test the functionality of our GUI and unable to implement a database. These two interfaces is our recommendation for next year's iteration.
The goal of Sprint 5 is to produce testing results by integrating the assembled product with the working code and prepare for Project Day. Our goal assessment concludes that we did not quite achieve the sprint goal, and here's why. We're still working on integrating the PCB board and the load, and the size recommendation algorithm has not been tested with the whole system.
Our recommendations for this sprint are going to apply to the next sprint, which will be for the class of 2020. Our proposed goal is for them to pick up where we left off. They need to integrate the GUI with the algorithm that we've created. They need to integrate the current transformer with the Raspberry Pi, similar to how we did with the voltage transformer. And they need to incorporate the long-term database in order to effectively predict fuel usage and efficiencies. Finally, they need to environmentally test the finished product for extreme conditions.